Reverberation, by definition, is a persistence of sound after it's been produced. So, a reverb is created when a sound is reflected to create large number of small reflections, thus creating a reverb. So, an effect that a sound would produce when bouncing, let's say, off the walls of a room we are in or any enclosed space we might be in. So, imagine a sound source like, let's say, your voice inside, let's say, a gym hall, and you say something, you can hear that reverberation effect when that voice of yours bounces off the walls and comes back to you. Now, the same thing can be said for any kind of sound source. So if you played music inside of a really big gym hall, you would hear that bouncing off the walls, you would hear that reverb. But what's really interesting is that you can actually recognize the size and maybe the type of the room you are in by just the reverb effect it's creating. So imagine when you're talking to somebody on the phone and they're talking to you from, let's say, a hallway inside a building, or let's say a bathroom. That's also really a nice example. You can recognize where they actually are. And how this is possible is because during your lifetime, you have actually experienced the reverberation effect of these rooms yourself. And then your brain manages to recognize that same reverberation. Now, depending on the surfaces that the sound is bouncing off of, the reverb has a different character. The amount of frequencies it's going to reflect back, let's say in a bathroom, the high frequencies are going to be reflected more since the surface is really a hard and polished surface, like tiles, bathroom tiles. And you can actually recognize that. And also, depending on the surface of the room, different frequencies reverberate longer or shorter. Meaning that in different rooms, different parts of this frequency spectrum are going to reverberate and stay in that room longer. So let's check that out in an example. I'm gonna play this electric piano right here. And this is that electric piano without any effect on it. Now when I add reverberation, and this is just a standard Ableton Live's reverb, so it sounds like it's in a room of some sort. Now, I can make that room sound different. So the reverb is creating an illusion of the sound being in a certain room. Now, without that effect, you can hear it's really dry. So it's only the dry signal. Now, when I add some reverb, I add some wet signal to it. So a reverb being a time delay based effect, we are actually adding something to the original signal to gain the illusion of reverberation. So at the same time, we hear the original and we also hear what's being added onto the original sound to actually get that reverb effect. I can show you what is being added to the original to create the illusion of that sound being in a certain room. Now, that being said, we can of course use reverbs as send effects on our send return tracks, but more interesting than that, we can make this reverb last longer. See that? Really long and really short. Without it. So adding just a tiny bit of room, tiny bit of ambience. Now we have some standard parameters in reverberation, and it's going to be this decay time or RT60. And that is the time it takes the reverberation sound to attenuate by 60 dBs. So it's going to take 2.41 seconds for this reverb sound, this reverberation effect we're adding, to fade out and become 60 dBs quieter than it actually was when it started propagating. The most noticeable a reverb is when the actual sound that's being reverbed actually stops, and then we just hear the reverb. Like that. So now I can make it longer, as I've shown you. So by making this decay time longer, I can make it really long. See that? That's really, really long. Let's make it less. Now, what else can we do? We can change the pre-delay time of this reverb. Now, the pre-delay time is the actual time that takes the first reverb to happen. So the first piece of the reverb to actually reach you. Now, what would this mean in physical terms? Well, that would mean that, let's say we were in a big gym hall and you said something. Well, it takes some time for the voice, for the sound you created, whatever that might be, even if you clapped or stomp your foot on the floor, take some time for that sound to get to the walls, bounce back so that you could hear it. So the bigger the room, the bigger the pre-delay time is. And that's the time it takes the reverb to appear after the sound has begun propagating. So the larger the pre-delay time, the bigger the room, because the walls are further away from you. Let's try to emulate that better. I'll make it short. You see, it's a bit late. So it takes 250 milliseconds for the reverb to start happening after the sound has been introduced into the reverb circuit. Now, some other parameters we might have would be the shape. And that would just be that decay shape of that reverb. So it could be like this. Takes longer time to dissipate. I'll just put pre-delay time back to 0. So that's almost a linear dissipation. And like this, it will be really logarithmic. See, lasts longer initially. And this one attenuates faster at the beginning, so making that shape of the decay of the reverb different. Now we also have stereo control in this reverb, so we can make that reverberation effect more stereo or less stereo. We also have the size parameter, which is going to kind of try to emulate different sizes of the rooms. Bigger the size, more diffusion, less size. It's going to be almost metallic, so really highly charactered, really colored. We can also choose the reflections. So we can choose the loudness of the early reflections, and every reverb, at least logarithmic one like this one, which calculates all the delays that happen in that virtual room with an algorithm, have those early and late reflections. Early reflections are the ones that come to you first. So the first reflections off the walls of the room that come to you, those are the early reflections. So we can make those first reflections louder or, of course, attenuate them. So we also have the diffusion volume, and that's the diffused reverb tail sound that you actually hear the most once I click anything. So that diffuse sound can be louder. See, like that. We can make that really quiet, and we just hear these early reflections then. And this is what they sound like alone. So those are the early reflections, the pieces of those reflections that go to the walls and come back to you first. So those are just the reflections. Let's say this is just the diffusion. Just that tail. One of the most important ones is the dry-wet parameter, where we can decide the balance between the dry, the original sound, and the wet, the sound is being processed by the reverb. How much we are adding the reverb. Now, just think about this for a second. If, let's say, you and the sound source, and let's say that's another person, were in the same space together, and let's say that's gym hall, because that's really characteristic with how it sounds. If that person was close to you, you would hear their voice and you would hear the reverb as well. But if that person moved far away from you in a room, you would hardly hear their original voice. You would hear the reverb much louder. So maybe their voice would even become indistinguishable or ununderstandable. So in that sense, in that balance of dry and wet signal, if the wet signal is louder than the dry signal, like this, that gives us the illusion of being in a room where the sound source is far away from us in that same room, just by us hearing the reverb louder than the actual sound source. But if it was the other way around, if we had more dry signal than the wet signal, so more original sound than the actual reverb, we have the same effect, but we are getting an illusion like that sound source is closer to us within the same room. Of course, in this reverb, we can also have some input processing, so we have some filters on the input of the signal, so we can cut off lows or high frequencies that are going into the reverb. We also have this diffusion timing, so we can, let's say, decide how much diffusion we want from certain frequencies, or let's say if we did that like this, we would just have the high frequencies added like this. Let's make that louder so you can hear it better. You see, only the high frequencies are being bounced. Now if I pull this downwards, now we have the mids too. If I do it really extreme, just like this, so it's really, really, let me play you only the reverb sound. See, only the highs. So this graph right here, which is the spectrum response like filter, is going to decide how long each one of the frequencies in the spectrum being fed into the reverb is going to last in this decay time. So saying that, let's say, low frequencies are going to attenuate much faster and high frequencies are going to last much longer when looking at this decay time. So it's not going to be the same decay time for all of the frequencies. I can make the high frequencies last longer in the reverb, and of course vice versa, make the low frequencies last longer and the high frequencies dissipate faster, like this. And right there we can characterize reverbs as dark or bright, just to start with. So bright reverbs, like the one you would have in a bathroom, like that, and we have dark reverbs, like a room that's covered with, let's say, some type of material that actually absorbs high frequencies, like, let's say, draperies and carpets on the floors, like that. So a dark room. All of those parameters on how long the tail is going to be at a certain frequency, they actually depend on the materials of the physical room that the illusion is being created for. Now let's try this reverb in some example where it's actually in a context of a song. So let's say I have this sound, like that, like a xylophone, really short. I also have this sound. And you see this one already has some reverb from inside the actual synth. I'm going to turn that off so we can add those ourselves. So I have some reverbs on these synths right here, and as I've told you already, the reverb being a time-based effect that actually adds something to the original sound to gain the illusion of that effect that we need, we can use them on send return tracks, and we talked about this in our digital audio workstation course. Now what I'm going to do is I'm going to, by using sends, add some reverb to these sounds. Let's say this one first. So I have two reverbs at my disposal. This one and that one. Let's hear the other one. Okay, so this one is shorter and this one is longer. I want more of the longer one. Like that, a big room. Let's see the other one. Okay. So a long reverb. Nice. A bit of the shorter one. So by using reverbs on sends, just like this, I can send one sound to two reverbs at the same time, giving it a more rich room at first. And second, I can give it two different rooms at the same time. So I can add two different reverberation models to one sound, making the actual reverb effect more complex. So let's hear how that sounds in a song context. And let's say without these reverbs, what that would sound like. See, really dry. So these reverbs actually help you in a production sense, move your sounds away from you. So we create a three-dimensional space in the actual sound image, in the sound stage of this song, by adding reverb to sounds and moving them further away from us. Now, we'll talk more about this in our mixing and mastering course. For now, it's really nice that you can hear reverbs, try them out. We have many different reverbs on the market from third-party producers of plugins. I can show you some others. Let's say this UV Spark reverb, and this one is really nice. It even has some randomization effects. It even has a really nice kind of a preset choosing matrix right here, where you can choose between presets. So we have presets already made, and then we can choose between them by just clicking like this anywhere in there, and with a moving parameter, see all the parameters at once. So I can move this, change that reverb. Let me try that with this sound. I'm gonna loop this so I can show you how the actual reverb is going to be changing. So that's a really, really nice model, how you could control all of the reverb's parameters at the same time. Now, many of the reverbs on the market are even more complex than this one, but in the next lesson we will learn about different types of reverberation effects being made. So we can have reverbs just like the one we had, algorithmic, but we can also have impulse response reverbs. Now we will go deeper into those in the next lesson.